Hello, today we will learn about physical layer in networking. In Module 2 we have these topics. Types of physical media, for example copper, fiber, wireless. Data transmission methods, for example modulation, encoding. Network topologies, for example bus, ring, star. Types of physical media, for example copper, fiber, wireless. There are several types of physical media used in networking to transmit data between devices. Here are some of the most common types. 1. Copper wires. Copper wires are the most traditional form of physical media and are widely used for Ethernet connections. They are available in different categories, such as Cat5e, Cat6 and Cat7, with varying speeds and bandwidths. Fiber optic cables. Fiber optic cables are a type of cable made up of thin strands of glass or plastic fibers that are used to transmit data over long distances. These fibers use light to carry information, allowing for faster data transfer rates and higher bandwidth compared to traditional copper cables. They are commonly used in telecommunications, internet services, and other data networking applications. Coaxial cables. Coaxial cables are a type of cable used for transmitting data or signals over long distances with minimal interference. They consist of a central conductor, which is surrounded by a layer of insulation, a braided metal shield, and an outer insulation layer. The central conductor carries the signal, while the braided shield acts as a grounding wire to protect the signal from electromagnetic interference. Coaxial cables are commonly used in cable television, internet, and telephone systems, as well as in audio and video applications. They are known for their high bandwidth capacity, low signal loss, and ability to transmit signals over long distances. Wireless media. Wireless media refers to the transmission of data or signals without the use of physical cables or wires. It uses electromagnetic waves to transmit data over the air and includes technologies such as Wi-Fi, Bluetooth, cellular networks, satellite communications, and infrared. Wireless media provides greater mobility and flexibility compared to wired technologies, allowing devices to connect and communicate with each other from almost anywhere. Satellite communication. Satellite communication is a method of transmitting and receiving data or signals using satellites orbiting the Earth. It involves sending data to a satellite using an uplink and receiving it back on Earth using a downlink. Satellite communication is used for a variety of purposes, including television broadcasting, internet connectivity, global positioning, and military communications. It allows for communication over long distances and in remote areas where traditional communication methods may not be feasible. In summary, physical media are the physical means used to transmit data between devices in a network. Copper wires, fiber optic cables, coaxial cables, wireless media, twisted pair cables, and satellite communication are all types of physical media used in networking. Data transmission methods, for example modulation, encoding. Data transmission methods refer to the techniques used to encode and modulate data signals for transmission over a communication channel. Here are some common methods. 1. Modulation. Modulation is the process of encoding digital data onto an analog signal. The two most common forms of modulation are amplitude modulation AM and frequency modulation FM. 2. Encoding. Encoding is the process of converting digital data into a specific format for transmission over a communication channel. Examples of encoding methods include Manchester encoding, differential Manchester encoding, and NRZ encoding. 3. Multiplexing. Multiplexing is the process of combining multiple data streams into a single data stream for transmission over a single communication channel. Examples of multiplexing methods include time division multiplexing (TDM), frequency division multiplexing (FDM), and wavelength division. 4. Spread spectrum. Spread spectrum is a technique used to spread a narrowband signal over a wider bandwidth to improve the resistance to interference and jamming. Examples of spread spectrum methods include frequency hopping and direct sequence spread spectrum. 5. Error correction. Error correction is the process of detecting and correcting errors in transmitted data. Examples of error correction methods include forward error correction (FEC) and automatic repeat request (ARQ). These methods are used in various communication systems, such as wireless, satellite, and wired communication systems. They help to ensure that data is transmitted accurately and efficiently over communication channels, even in noisy or congested environments. Network topologies, for example, bus, ring, star. Network topology refers to the physical or logical layout of a network, which determines how devices are connected and how data is transmitted. Here are some common network topologies. 1. Bus topology. In a bus topology, all devices are connected to a single cable, called a bus. Each device communicates directly with the other devices on the bus by sending data signals to the bus. Bus topology is easy to set up, but it is susceptible to cable faults and collisions. 2. Ring topology. In a ring topology, all devices are connected in a closed loop, with each device connected to the next device in the ring. Data signals travel in one direction around the ring until they reach their destination. 2. Ring topology provides high-speed data transmission and is less susceptible to collisions than bus topology. 3. Star topology. In a star topology, all devices are connected to a central device, such as a hub or a switch. Data signals travel between devices through the central device. Star topology is easy to set up and provides better fault tolerance than bus or ring topology. 4. Mesh topology. In a mesh topology, all devices are connected to each other in a point-to-point manner. Data signals can travel directly between devices without passing through a central device. Mesh topology provides high reliability and fault tolerance, but it requires more cabling than other. 5. Tree topology. In a tree topology, devices are arranged in a hierarchical structure with multiple levels of interconnected devices. Data signals travel from the higher-level devices to the lower-level devices until they reach their destination. Tree topology provides good scalability and fault tolerance. 6. Hybrid topology. In a hybrid topology, two or more different topologies are combined to create a more complex network. Hybrid topology provides the benefits of different topologies, but it requires more planning and management than other topologies. Each network topology has its own advantages and disadvantages, and the choice of topology depends on factors such as the size of the network, the type of applications used, and the budget available for the network. Thank you for watching us.